I don't have my mic on properly. All right. Okay, hi everybody. I'll just wait a minute. There's a few people coming. I'll wait a minute before we get started properly. Hi everyone at home. If you're at home as well and you want to attend lectures in person, you can. There's room if you feel like coming in occasionally, all the time, whatever you like. All right, we'll just start in about 1 minute. Okay. Can't see properly. Okay, let's get started. So, hopefully everyone can hear me up the back. Yeah?
Hello?
Yep. Hands up if you can hear me at the back. Okay, cool. All right. Okay, we're going to get started now. So, today we're talking, welcome to week 3. And we're going to talk about functions and style today. Last week we threw a lot of new stuff at you. We will do a bit of a recap today on nested while loops and structs. And then we'll also do enums, which we didn't get time to do last week. Also remember that a lot of the stuff that we're showing you now, it's getting more complicated. So you might not understand it the first time you hear it. Some of it you might need to go away and try out problems. And that's what the tutorials and labs are for. So if you're still sort of finding nested while loops tricky, that's because they are tricky. but you'll be doing them this week in your tutorial and labs. And you'll be practicing them over the next couple of weeks, okay? And so it's like all this stuff, don't panic. Excuse me, I'll just have a sip of water. You'll have plenty of time to practice and sort of get on top of the skills. Yep?
Is it okay to not do the skull problems in the week there are two skull problems?
Can you repeat that?
Like after 3 dot problems,
Yep.
there are 2 problems with skull emoji.
The skull emoji problems.
They are just for funsies.
Yeah.
If you want a bigger challenge.
Yeah. We often, there are questions we give that are just for challenges. Some of them are really, really, really challenging. So it's great to give them a go if you're on top of everything else and you've got time. But, you know, you don't have to do them. Yeah. All right. Another reminder, how's everyone gone with their week 2 lab? Has everybody submitted all the exercises? If you haven't, you've still got until 8 p.m. tonight. But yeah, just don't forget to submit them. And we've got lab 3, and again, now we're on this regular schedule where you'll be submitting these labs each week. The exciting thing is we've got our help session schedule up now. Has everybody had a look at it? So help sessions are where you can go and drop in either in person or online and and get help one-on-one from a tutor. And this is our beautiful dark mode. We can now swap between light mode and dark mode on our website. And that's thanks to Sophia, who's like amazing. It doesn't look good on the projector. It looks really good on your personal screen if your eyes get tired. All right. But here's the timetable. Oh, I've got the wrong timetable.
Yeah, there's two timetables on the website now. That's the one down.
Where is it? I was looking at it last night.
Yeah, that one. You were there.
Oh, help sessions. Okay. I'm just going through the motions of what you'll all do maybe. So yeah, here's the timetable for the help sessions. They start this week. You can get help tomorrow night from 6 o'clock till 8 o'clock online. But go through here, go get help if you need it, okay? This is all on the website, all right? If you go to the website and go to this help session timetable here, you'll find them all. All right, let's get back to, well, not let's get back, let's start. All right. Oh yeah, we've also got assignment 1 coming out early next week, all right? And we'll talk more about it then. So look, let's just get started. We're going to do a bit of a recap with loops and nested loops. And I've already said things are getting hard, but it's just a matter of practicing and not avoiding it. The more you do it, the easier it gets, yeah? And the more you avoid it, the harder it gets. Our week 3 code's available, as always. All right, so let's have a little bit of a look at loops just very quickly. Oops, I've already wrecked what I was going to do. If we have a look at this if we have a look at this code here, what is this going to print out? So this is just a one-dimensional loop, or just a single loop. So we're setting our variable col. We're checking if col is less than size, which is 5. 1 is less than 5. So we're going to print out 1, right? Does everyone agree? Then we're going to increment col. Now col is going to be equal to 2. And 2 is less than 5. We're going to print out 2. We increment col. Col is now equal to 3. So now 3 is less than 5. We're going to print out 3. And now we're incrementing col. Let's keep track of it now, my brain. Col is now 4. 4 is less than 5. We print out 4. We increment col. It's now equal to 5. What happens now? The loop finishes. So when the loop finishes, it jumps down to this closing bracket, and it's going to print new line, which, yeah, I just printed that out there. It's complaining. Now, if we were trying to print out 1, 2, 3, 4, 5, which I'm pretending we were, this isn't right, all right? This isn't quite right. And this is the kind of error you're going to get a lot when you do loops. You'll be off by 1. But this is easy. You can look at it and think, oh, I wanted 1, 2, 3, 4, 5. I've only got 1, 2, 3, 4. What do we do to fix this? Sorry? Yeah, we put a less than or equal to here. And in this situation, this should fix it. Oh, well. Okay, so that's our one-dimensional loop. Is everyone sort of happy so far? Now, what if we want to do this kind of pattern's a bit harder, but what if we just want to do a pattern like we did last week, 1, 2, 3, 4, 5, but we want to do it 5 times? Well, this is the kind of code we can do. We're taking this code that we've already just looked at, and we know that that prints out 1, 2, 3, 4, 5, and we're putting it inside a loop. If we look at this loop, we can see row starts at 1, row goes up to less than or equal to size, so we know it's going to go through for row equals 1, 2, 3, 4, 5, right? If we just look at the parts that I haven't highlighted in blue. And so what it's going to do, it's going to do this inner loop 5 times. This is going to give us these 5 rows. So if I compile this, I'm going to get these 5 lines, right? But what's happening at any given point in time, like as we're iterating through this, what's sort of going on? I'm not going to go through it for the whole 5 by 5 thing, but first of all, we've got row is equal to 1 and col is equal to, right? And then we go to here, 1 is less than or equal to 5, and we initialize col to be equal to 1 as well. And we print out, because 1 is less than or equal to 5, we print out a 1. And this is how we get this particular 1 printed out. This is when row is 1 and col is 1, okay? Now we're going around in this inner loop again and again and again, and we're incrementing col, and now it's still printing row 1. Oh, we're up to row 1, col 2, and we're printing this 2 out, right? Our row variable was 1, our col variable was 2, and we're printing this 2 out. Does everyone agree? Now we increment col again. So col is equal to 3, row is still equal to 1, and that's when we're printing this 3 out, right? We keep going, we keep incrementing col and printing out col, incrementing col, printing out col. Now eventually our col is 6. This loop condition is no longer true, so this loop stops and we're down to here, right? And then we print the new line. I'll just do it as a dash. That's the new line. Now, once we do that, this row then increments. We've ticked over to the next row, and this is now 2. And we check, is row less than or equal to size? Well, 2 is less than or equal to 5. So we go through the loop, and this is really important here, because right now, our col was 6. If we don't reset this to 1, our col is going to be 6, and we're just going to say, no, well, col is not less than or equal to size, and we're not going to print anything out. So this is a really common mistake, not resetting your variable for your inner loop. So you can try that later. You'll just get one row of data, and then the rest will just be new lines. So at this point, we reset this to 1. And now we're on row 2, but we're just printing out the column. And we're printing out 1, 2, 3, 4, 5, whatever. This happens again and again and again and again until eventually row gets to 6 and we stop the whole thing. Is everybody sort of happy with that? And you can continue with that if you think that way of thinking helps you understand it. Go through it like that, tracing through the variables. Now, if we want to do, I'll just get rid of all this for now. If we want to do a more complicated pattern like this, let's have a look at it. So sometimes we're printing numbers and then a space. Sometimes we're just printing spaces. When are we always printing numbers?
The odd columns.
The odd columns? Yeah. Every time we've got a column that's odd, we're printing a number, right? So even if I just try and do that, I can put that into my code by having some kind of if statement inside my while loop. So inside my while loop, I can just check, well, I definitely want to print this if my column is odd. So I can check if something's odd by saying mod 2. If it's odd, what will or will it not be equal to? You can check if it's equal to 1, and that's going to work in this situation. If we've got negatives, checking if it's equal to 1 won't work, but we don't care about that now, so this could work. Otherwise, sometimes it's just nice to say it's not even, because that'll work in situations where our number's negative. But now, if it's not odd, if it's even, we want to print out just spaces, 2 spaces like that. So let's try this. Now, this hasn't addressed all of the criteria that we're interested in. So now we've got it like that. We're doing an if statement. If the column is odd, we're printing the number. If it's not, we're printing spaces. But what do we do? When else do we want to print it? Let's look up here. So we're missing these ones. We always want to print it when it's, at the top row and the bottom row. Does everyone agree? Yeah? Yeah?
So like, what if we could do call plus 2 is equal to call? That would print 1, 3, and 5, right?
Yeah, and look, there's probably lots of different ways you can do this, right? You can go away and do it lots of different ways, try it, and that will probably work doing things like having a counter and saying plus 2 and then, going up by 2s or something. You can try it. It depends exactly how you do everything else. But that kind of idea might work, yeah?
If our if statement has a statement where row equals to 1 or row equals to 5.
Exactly. So the other possibilities are we definitely want to print a number if our row is 1 or our row is equal to size or 5. So I can just make this more complicated. Do I want to put ands or ors in here? Ands or ors? So just think, if row, does it have to both be in row 1 and in an odd column? Does it have to be in an odd row and in the first, no, does it have to be in an odd column and also be in the first row to print a number? Both of those things. So do we want to print this one here? Is that in an odd column? So we want to print it if it's in an odd column, or if it's in row 1, or if it's in row 5. So it's very, you're going to want to do an and there, because we want these situations, this situation and that situation, but I'm doing the wrong thing. Row equals size. Okay. So let's try this. Maybe I'm wrong. Let's see. Okay. So this is just, we're adding if statements inside our while, nested whiles, to sort of change the behavior. So you're going to practice all this stuff this week. I also wrote this program called clock. Now this is not a real-time clock. It's printing out the hours, minutes and seconds over a whole day. So you're lucky it's not in real time because I'm going to run it. But it just prints out all the different times. It just ticks over. And it doesn't take that long. But I've done the implementation. You can have a go at doing it. Basically, it's some nested loops. We've got a second counter that's ticking through, a minute counter that's ticking through, and an hour counter. Don't worry so much about the formatting. You can try that, but I've got the solution for you to look at later. Try it out. Because I think that really shows you how the variables are changing. And it's like 3 loops, like it's nested, nested, nested. All right. Which is kind of not what we would probably expect you to write in this course, I don't think. They don't ever do 3 nested loops, do they? Or do they? Maybe they
might get themselves to do one if they problem solve it that way.
Oh yeah, well you might, but yeah, all right.
Not normally.
Okay, but I think it really shows you how the loops work. Okay, so yeah, this is all a bit brief again, I know. Structs. So we did look at structs, but we didn't have time to go into them in great depth. So I'll just do a little bit of a recap on those as well. So remember, what are structs? Oh, I've got the wrong code open. Yeah. Structs, I've still got the wrong code open. Sorry, guys. Does anyone remember what structs do? Why would we use a struct? Yeah? Yeah, we're putting related data together in one variable. So here I've defined struct student. So I'm telling C that I want to be able to create variables of type struct student, and I want you to be able to give me enough memory to store all of this stuff about a student together. And I've decided I want to store their first initial, their last initial, their age, their lab mark. Why am I storing initials? We haven't learnt yet how to store, whole people's names yet. We'll learn that next week. All right, so down here, we've got our variable. So when I say struct student Brianna, this is the type. You know how we might say int and declare a variable. This is the type. This is the name of the variable. So we end up with a chunk of memory that just has garbage in it at the moment. Now, to set the individual pieces of data inside this variable, we use this dot notation. So we're saying Brianna dot first initial, and we're setting that in there. Brianna dot last initial is K, Brianna dot age, Brianna dot lab mark. So that's all in one sort of chunk of memory together that we can access via these dot operators. Now, if I want to print these out, I have to do the same kind of thing. Oh, I've decided to, before I print it out, I've decided to modify one of my variables. Remember, these can be modified like any normal variable. I can go and say Brianna.age. Actually, she's 22 now. I don't think she actually is. This is just made up stuff. Now to print it out, I'm going to have to do Brianna.firstInitial %C. I'm going to go and print it all, each individual member of this struct. Because printf didn't read my mind that I would want some kind of struct student and doesn't have any % student thing that can just print it out for me. All right, is everyone sort of happy to hear? Now, I've made another struct. I've got another variable called struct Tina. And this time, I'm not hard coding all the data in, I'm reading it from a user. And this just works the same way it always works. We can use scanf. And when we use scanf, we have to read something in, we have whatever our variable is. So in this case, I'm saying Tina.firstInitial, and I've always got to put the ampersand in front of it. So this is nothing really new. I'm just showing you, it just works the same way like this. You've got to say Brianna dot, whatever little piece of data you're doing, the first initial is a %C, and it can read it into those variables, right? And then we have to do it for all of the different fields. Whatever the user types in will go in there, whatever it is, and then we can print it out. Okay, yeah, we've got a question?
So my question is that when we declare a struct variable, so whatever values we store in struct variable, we only need to use the format specifier. We don't need to use int, char, etc.
We've already kind of done up. So we've already said inside this struct what type all of these little subcomponents are. So we don't have to do that again. When we say dot first initial, we've already told C, well, first initial is a char. Yeah. All right. There's another example here that we kind of looked at called struct points. Again, let's just run this and then I'll talk about what it does. Actually, let's not run it. Let's try and work out what it does. So okay, there we go. I've got my struct coordinate. I've defined this. I've decided a coordinate has an integer x field and an integer y field. Then here I've declared two struct coordinate variables. I've called one 0.1. I'll just put a 1 there. I've called 1.2. I'll call it P1 in my drawing and P2. At the moment, they've got garbage in them. I'm putting the values 0, 0 in the first one. I've set the dot x, the dot y. I've put the values 10, -5 in the second one. Okay, is everyone sort of happy to there? Now I'm just printing them out. I'm printing out 0.1.x and 0.1.y, 0.2.x and 0.2.y. Again, we can't just shove the whole point into printf. We've got to do it piece by piece. Okay, now the next line, I've got 0.3 equals 0.2. Now, without me telling you, it's hard for you to know what this might or might not do, but it just basically creates another point called 0.3, and it just has the same values in it as 0.2. So it's basically a copy of 0.2. We've got two copies with the same data in it. Is everyone happy with that? All right. So these are the three structs we've got right now. Now, if I do this line here, I'm saying 0.3.x equals 0.3.x plus 5. Well, I'm adding 5 to this thing here. So that was 10. It should now be 15, right? Hopefully, it's clear that 0.2 hasn't actually changed, right? So when we said 0.3 equals 0.2, we copied the contents in. We've now got two separate copies. We've modified 0.3. 0.2 is just the same. Okay. So when we print all these points out, we're expecting it to print, well, let's just see. Oh, it's called struct points. Okay, 0.1 is 0, 0. 0.2 and 0.3 were both 10 and -5. 0.2 is still 10 and -5, but we updated 0.3 to 15 -5. So again, this is just something to refer back to or play around with to see what happens when you're modifying structs. And that will become important later, that we can make one equal to another struct and it becomes a copy. All right. Let's Oh, I haven't even done that. So don't worry too much about the points and making the copies and that. If you understand the whole idea of structs, that's good. So here's enums. Yeah?
Is there any difference between struct in C and classes in Python?
Is there a difference between,
Struct in C and classes in Python.
sorry, I'm not sure what you're saying. I think you're trying to compare something in C to something in Python.
Yeah, there are classes in Python, right?
Ah, right. Yeah, look, I think some people asked that the other day about Java and classes and stuff like that. It is a bit different, but yeah, that's a good question to ask on the forum or the chat so I don't confuse people who don't know about Python. But yeah, it's not exactly the same. But yeah, you'll be doing this the whole time if you know another language, thinking is this similar to that or different to that. Yeah, but that's good actually to do that. But they're not exactly the same. Now, we're looking at this thing called enums. These are an alternative to hash defines, basically. This allows you to have like a set of integer constants that are related. And it makes it just easier. So, for example, we use the keyword enum. We create a name. This enum is called weekdays. And then we can just define all the constants we want for days of the week, Mon, Tu, Wen. Like, so it's a set of constants that are all sort of related, right? And it's saying anytime you create a variable of type enum weekdays, these are the different values you can give them. They're actually just integers though. So by default, they'll be 0, 1, 2, 3, 4, 5, you know. So it's a little bit like, say, the other way you could do it is have hash defines with Monday equal 0, or not equal to 0, and Tu 1, Wed 3, etc. One of the benefits of this though is this is kind of more compact. You don't have to assign the numeric constants yourself, which is quite repetitive, and you can accidentally say Mon 0, Tu 0, you know, you might mess it up a bit. This will make sure they're unique and sensible. And there are some other advantages we'll talk about. Sometimes we don't want the default 0, 1, 2, 3, 4, 5 values, so we can hard code in some values that we want, like in this error code case. Yep. An enum, we haven't done arrays yet, but this isn't something we can store lots of different data in. This is, I'll show you in a minute. This is like saying I can make my variable either equal to Monday or Mon, or I can make it equal to Tu, or I can make it equal to Wednesday. It's just like a set of like hash defines, but done in a sort of more formal way. Okay, yeah?
So for enums, we put a set of variables and it will come out as an output.
It's basically, yeah, it's just a set of constants. Think constants. Think like hash defines, but a set of them. So let's just...
Is it possible to do it the other way around?
No. And I'll show you in a second. So just let me finish this example. So I've got code here. If I've got this enumerated type, I can create a variable called, oh, sorry guys. I can create a variable called enum weekdays. Again, this is my type. My variable is called day, and I can make my day equal to sat, right? I can make it equal to one of these values. Now, unfortunately, if I try and print this out, it can't print Saturday for me. It can't print sat for me. It's going to print 0, 1, 2, 3, 4, 5. Okay? So if I wanted to print out Monday, I would have to have if statements, and I'll show you that in a second. There are sort of other possibilities to do tricky things, but this is kind of what we'd need to do. So this time I've made it Wednesday. This would print out 0, 1, 2. But I've got this sequence of if statements that could print it out, right? So let's run this. So by default, if you just printed out %d, that's the only way printf can help you. You're going to get 2. You'd have to have these if statements. Now, wouldn't it be good if we could write our own kind of print function that knew how to print out weekdays? So if we wanted to print out these variables all the time, we could just use that instead of copying and pasting and rewriting this horrible if statement, chained if statement again and again. We're going to see how to do that today. And one good thing about these that you don't get with a hash define is I can't just use the wrong constants from don't belong. So I can't then, I've got these enums for the months of spring. I hope I got that right. I can't say day equals September, right? It's C will do some type checking and go, no, that's not a valid value to give it. If we'd done all hash defines, it wouldn't know. It would just let us do it. Okay, it doesn't stop us doing everything that we could do wrong or stupid, but it helps a bit. Okay. And then that's all enums are. Another alternative to hash define when you've got a set of integer constants. It doesn't mean we're never going to use hash define again. So in our example before, we had hash define size 5. It was just a standalone thing. We don't necessarily need to make a whole enum for that one constant. We might have other hash defines we use when we don't have integer constants. We might have pi. You know, that's not going to go well in an integer enum type. Okay, one more thing that we're going to join these together. So we've seen structs, we've seen enums. Now we've got structs that can have enum fields or members. So these are just another type now. So here I've got enum student status, enrolled, withdrawn, leave. Now I've just made this up. I didn't get this from the Student Hub. I don't know that you can go and leave. I don't know. Don't email them about this. So now I've got a struct student. In my student, I've got a status and it's an enum type, right? And I've got another field, wham. And I just use it as normal. I can create my struct student, give it a variable name, and I can just say dot status and set it to one of these values, okay? Does this make sense? So when I've got a struct, I use dot, so dot wham, I can set that to any kind of double value. Dot status, I can set that to any one of these enumerated types. And that's what I've done. All right. Hopefully people aren't completely lost. Does anyone have any questions because they're just not sure at all rather than like fine details? Yep.
Where it says enroll, what if you put it once, that it has to be the where it says enroll, what if you define that as 1 or 0 for the integer?
Oh, you could say equals and give any number you like. So yeah, something like, oh, I've lost the slide. I'm going the wrong way. Yeah, you can do something like this to hard code whatever, define whatever values you want instead of just the defaults 0, 1, 2. Is that what you mean?
Like rather than calling it by its name, what if you put in the integer value? Would it automatically know that that corresponds to?
Well, I think if you put the integer value 1 in there, it'd probably treat it like the string one. I've never tried it, actually. Yeah, try it. See what happens. But that would be confusing because then if it worked, it would be saying 1 and it would have by default, the first one will have a constant of 0. Yeah. I don't know if it's a legal enum name to start with a digit. Yeah, let's see quickly. Now I want to know. Yeah, I don't think it's letting us. Yeah. No, I think is this what you meant? Like actually calling it 1? Yeah. No, you can't. Doesn't let you. That's different to saying, I want you to call September 1 instead of 0, which we can do. Okay, I think, yeah, the names have to start with letters. All right. Here's an example, and we're going to come back to this example later with functions. Yep, we've got a question?
If in an enum we give values to some of the enumerations, so what will be the value of the other one?
All right, so if you gave this one the value, so here's another enum, Pokemon types. If you said fairy to be 400, fire would be 401. It'll just keep counting up until you supply a different number. Most of the time, we don't really care about the underlying numbers, most of the time. Okay, so here I've got another example where we've got a struct, and I'm not going to go through all of the details of this. I just want you to see how helpful functions are going to be. But I've got a struct, and don't tell me that this is all wrong information about Pokemons. I'm sure it is. I've given them hit points, combat power, speed, and a primary and secondary type. So some of this stuff might be right, some of it might not be in terms of Pokemons. Down here, I've made a struct Pokemon. My variable name is Jigglypuff because I like singing. And I've just made up some bogus pretend hit points, combat power, speed, and I've given it fairy and normal. Okay, which I think's right, but it doesn't really matter. Now, if I want to print out the stats of this Pokemon, right, I can come down here. I'm writing Pokemon stats. Let me just run it, actually. I'm printing out that, right? That looks so easy, doesn't it, to print? That couldn't possibly be hard or painful, but it kind of is. So I've had to say Jigglypuff.hit points, Jigglypuff.combat speed, Jigglypuff.speed. To print out fairy and normal, I've had to go and look at the primary type and do if, else, if, else, if, else, if. And I didn't really even put all the different types of Pokemons in there, right? And then I've had to copy and paste and change that code to print it out for the secondary type. So just to print out this small amount of data, I've got all of this code, and my main function is getting really long and really ugly and confusing. Now, does everyone agree with that? Okay, good. So we're going to see today how we could make a function that, say, prints a Pokemon or prints a Pokemon type. And then we wouldn't have to keep copying and pasting sort of code like this. So that's what we're going to be doing in the next half of the lecture, talking about how to write functions to break up our code, and so we don't end up with mains like this that, yeah, you just don't want to look at it. Yep.
So if we don't define like one of the things in the struct, for example, if we just doesn't have a secondary type, we don't give it a secondary type, will we still be able to like access the other data, or do we need to define all of them?
It should work as long as you don't go to that individual field. Yeah. Typically, I'm pretty sure that is what DCC would do as well. Okay. All right, so that's that. So don't worry about looking at every single line of this code for now. Just the idea of we need some functions. What's the time? I've still got time to start functions before the break. So hands up who thinks you've seen functions before. Okay, most people are saying, yeah. Where have you seen them? Oh, maths. Not exactly that type of function. So you've been writing functions. Yeah, you've been writing main functions. But we can now have more than one function in our code. You've been using functions. Scanf, printf. They're like library functions, yeah? And the good thing about printf is, now that you know how to use printf, that's just one line of code that does something. If you went and looked at the printf implementation, there's a lot of code there. You wouldn't have to, even if you understood it and were capable of writing it, which a beginner wouldn't be, you wouldn't want to have to keep writing it, and your program would be filled up with all this code instead of having the beautiful printf statement, which now doesn't look so cryptic to you anymore, right? You think, oh, that's printing something. So you have seen them, but we're going to learn how to write our own functions as well. And we'll find out exactly what void and return mean. So a function's just like an independent, reusable block of code that performs a specific task. So think printf. You know, printf's actually a complicated one, but you know that it's going to print out something for you. You don't even have to know how they wrote the code. You just have to know how to use it. So it makes your program easier to read because you're using a function instead of having all the code in the way. It avoids duplication. You don't have to keep repeating, copying and pasting the code that they would have written for printf. You can just call the line printf. It also does something called abstraction, which is important in computing. We don't want to know the details of everything because software gets quite complicated. We don't want to know all the low-level details of things that don't concern us. We want to solve the problem. So we don't want to know how they wrote printf. We just want to be able to print something out. And it's going to allow us to test things in isolation. So we can test and make sure one little function works. And then when we use it, we can be fairly confident our bug is not coming from that place. Yeah. All right. So functions have things called parameters. So the parameters just basically tell you what inputs the function needs. So sometimes we call inputs arguments. Sometimes I just unofficially call them inputs. And we've seen a parameter list already. So when we say int main void, that void is telling us the main function needs no inputs. And I'll show you some examples in a minute. Now, a function may return a single value. So again, in int main void, we've seen that int, that's the return type. And return type, we've seen it return 0 at the end of our code, right? So I'll explain that in more detail. Void means you're not returning anything. So void input means there's no input. Void return type means there's no return, you're not returning anything. Kind of means empty, nothing. So this is like a standard sort of function prototype. The prototype of a function is basically what is the name of the function? This function is called maximum. What are the parameters? In other words, what inputs do I need to give this function? So this function maximum takes in 2 integers. What return type is it? What does it have? So what answer is it giving me? So I'm asking it a question. So I might say to you, what's the maximum of 10 and 5? And you'll tell me, yeah, you'll return the answer 10 to me. So I'm kind of asking a question. I'm giving you the inputs you need to answer that question. You're returning an answer to me. And then I can do something with that answer. So this is the prototype. Notice we haven't seen how they've done it. We haven't seen less than, greater than, anything like that. The prototypes are important for 2 things. Like later in the course when we start looking at libraries of code, they'll show you the prototype and maybe some comments. And from that, you get a really good understanding of how you can use that function yourself. Also, the compiler uses it. So if you're trying to use this maximum function and you're not giving it 2 integers, the compiler can say, no, that's not how you use this function. Yep.
So I can put a function inside that function for that function to grab that function and see the maximum of that function.
You can, look, there are things like pointers to function that we will not cover in this course. So yes, you can do all sorts of things in C, but we're not going to do it or discuss it because it's too hard for this. But yeah, Google function pointers, I think that's sort of what you mean. And you probably might have seen stuff in other courses. Yeah, we're not going to talk about it. We're not going to talk about it. So forget everything you just heard. All right. Oh, we can skip over this. Here I've just got an example, and after this example, we'll have a quick break. I've got 3 prototypes up the top. I've got maximum, we've talked about that. I've got a function called print stars. Now, when I want to use the function print stars, I have to tell it how many stars I want it to print. And it's going to go, and when I say stars, I just mean asterisks. It's going to go and print out, you know, however many stars I tell it. Now, I'm not really asking it a question. I'm not saying, can you tell me anything? I'm giving it an order. Go and print these stars. So there's no return type. It's just supposed to go and do it and then kind of leave me alone, you know. Here I've got, because of that void return type, here I've got print warning. I don't have to tell the print warning function any information. I just say, go and print the warning. It should have enough information to go and print out some warning message. I don't have to tell it anything else. There's no input. I'm not asking it to give me any kind of answer. I'm just telling it, go do what you know you have to do kind of thing. Now, down here, I'm using these functions, right? Let's just look through this main function. I've got num7. It's just a variable. This is good. Nothing too hard yet. But now I'm doing, we call it a function call. I'm calling the function. I'm saying I want you to go and tell me the maximum of 10. And, well, when I pass in num, I'm just really passing in the number 7. It just sends the value that num stores, and we're asking, what's the maximum of 10 and 7? If this function works as to its name, it's going to give me back 10. And I'm going to store that in a variable that I've got called max. So is everyone happy with that? Our maximum function is going to take in 2 numbers and give us back the maximum. I can assign that to a value and then use it in my code. All right. On the next line, I'm calling my print stars function. Now, we haven't seen the code for this, but we're assuming I've passed in what value? 10. Yep, the 10's in this variable here. I'm saying go and print out 10 stars. So the print stars function at this point should now go and print out 10 stars to the terminal. I'm now calling print warning. It's going to print out a warning message. So this is how we can actually use these functions. All right. If I've got a void return type, I can't like say this equals this function. Like I can't assign it to anything. All right. Now I'll go through this in more detail after the break. I just want to show you the implementations. Actually, let's have a break and then I'll go through it in more detail. All right. Because it's 5:02. So we'll come back at about 5 past and we'll keep going. One second. Sorry. Hello? Oh, cool. It's on. Welcome back from the break. I'm going to actually just show you. Shh. Don't forget to shut the door. Bye. I'm going to show you the actual whole program and how it fits together. So up the top, I've got my prototypes, our 3 prototypes. I've got the main function. The main function is going to be calling these that we've written. The actual code for these functions is down here. So my maximum function has 2 inputs. So if you want to use this function, you've got to give it 2 integers. It's going to go and try and work out which one is the actual maximum. And it's, it's got a variable called max. And it's saying, well, let's assume x is the max. And if x is less than y, then maybe y is the max. So don't worry about this code too much, but it's using if statements to work out which is the bigger number. When it works out what the bigger number is, it returns that number. So if I input the values, I don't know, 5, in this example, when I'm actually calling this, let's see what I am doing. I'm passing in a 10, right? The value 10 is the first integer I'm passing in when I'm actually using this function. The second integer I'm passing in is what? So up here, I'm saying I want the maximum of 10. So that's passing in the value 10. And then num. What value does num have? 7. So this is just really passing in the values 10 and 7 into this maximum function. So the maximum function, they'll have their own sort of copy called x with the value 10 in it, and their own little sort of variable or parameter variable called y with the value 7 in it. Does that make sense? The 10 in this function, the x has the 10 in it, the y has the 7 in it. Is everyone happy to there? So then we've got this, what we call a local variable max, that this function is using, and it's saying, okay, let's assume x is the maximum, right? And then it's just checking, well, actually, let's compare x to y. If x is actually less than y, which is not, we would make the max y. By the time it's done those if statements, it's worked out that the max is 7. So does everyone agree? Like we've got a variable in this function called max, and it's worked out that the maximum of 10 and 7 is 10. To actually, any questions about that? Now, if you're a function and you've got to return an int or give back an integer answer, you literally have to write this line, return. And you're saying return max. And what you're doing is basically sending back the value 10 to the person or whatever called your function. They said, give me the max of 10 and 7. You're returning, in this case, the value in this variable, which is 10. Okay? And you've got to make sure, if your return type is int, that you're returning an int. And we are. We're returning the value, in this case, 10. And that value gets sent back, and we can store that value here and then use it again later. So back in the main has a variable called max, which now, after this function is finished, it'll have the value 10 in there. Okay. Now, let me just say, oh no, I won't say that now. Once we've done that, so that's a function call. So our execution is going to start. Every time we run a program, the execution starts in the main function. We execute it line by line. So let's just actually run through it. And we have num, which is a variable inside where the main store all its variables, right? When we get to this line here, we're doing our function call, and that means the system is going to keep track of where we were up to in the main function. So it knows where to jump back to, but it's going to jump down and execute this function. We already know we've passed in the values 10 and 7, right? Inside maximum function, it's got an area with its own personal variables. So it now knows it's got a value 10 for its x and a value 7 for its y. It then also has a variable in it called max. It does some calculations and comparisons and whatever to work out that actually the maximum between these two values is 10. Down here, it's saying, I'm done. The output or the return value is 10, and it sends that back. Okay? At this point, this function's gone, and actually, even all these variables are gone. Because, you know, the system can use that space for something else, right? But back in the main function, we're going to store that value 10 in our own variable. Okay? Is everyone happy kind of to there? And then the system keeps track of where we were up to. So I'm just going to get rid of all this now. The system keeps track of where we're up to, and it knows we just executed this line here. We're going to continue executing from where we were up to and execute this line here now and continue. Now, when we get to this line, we're calling another function. What value are we sending into this function? So we're saying print stars max. What value does max have in it now? Yeah, 10. So now the input we're putting into the print stars function is 10. And the system is going to keep track of the fact we were up to this line of code, but it's going to jump down to print stars. And it would have passed in the value, in this case, we passed in 10. So this function is going to have there we go. This function is going to have its own variables, right? It's going to have a number of stars variable, which has 10 in it. That was like a parameter and an input. Yeah, question?
The orientation doesn't seem to matter because the computer knows to jump down, can it like jump up as well so that the orientation of all of these functions?
Oh yeah, now it can jump around so that you don't have to strictly have all the functions in the order that you're going to call them, because you might be using some of them more than the other, but it's going to jump to that function. Yeah, sorry.
And what's the difference between void and int?
I'll explain that now. Yeah, cool. So, yeah, I've given the input of 10. This also has a local variable I. It's going to go around and do a while loop. And that's not the focus of what we're looking at now, but this is going to go and print out 10 asterisks, right? Doing this while loop. And at the end, it's going to print a new line. Now, this particular function has a return type of void. So this function is just doing something. It's not sending any data back to my main function for my main function to use. It's just going and doing something. So when it finishes, it just finishes when it gets to this last line, basically. It doesn't need a return statement. It can have a return statement, but it wouldn't return any value. The return would just say, I want to finish my function now. Because the function will finish when it gets to the last line or it sees the keyword return. So when this finishes, again, all of these variables in this function are sort of gone. They don't exist because that function's run. if it runs again, it'd need fresh variables anyway. Now the system knows that we were up to this line of code, so it knows to keep continuing. And the main still has all of its variables sitting there, because the main function, we never finished that yet. We're still going with that one. We get to print warning, and we jump to the print warning function. Again, it happens to be down, down here, but wherever it is. And now we just start executing this. Now, because there's void input, when we asked this function to run, when we called it, we just use these open brackets because there's no input for this function. The function, all it's doing is just printing out this. It doesn't need any extra information to do this task. It's not sending any data back to the main program, the main function to use. It's just doing something. So it's got an input void and also return type void. Now, when it gets to the last line here, again, that function finishes and it will jump back to where it was up to in main, and it's going to execute this next line. This next line says return 0, because now the main function is finishing and it's passing this naught back, which is an int. Where's it going? We don't really care in this course. Our work's done in this course once we get to return 0. In another course or in other situations, a program that's running our program might examine that variable to see if we crashed, we were successful. For us, we're done. Return 0, it's all good. Yeah, so that's how the whole thing runs, and that's how the function calls work. We're jumping to different pieces of code, but then the computer keeps track of where we're up to so it can continue from where it was going. We're passing in like copies of our variables into these functions, the values or values, and they have their own copies of variables in those functions. Okay, so if I run this, I haven't even run this yet. Well, this is all it does for all that explanation. Maximum never printed anything, right? Maximum just returned data to us to use. Print stars printed out its 10 stars like we told it to. Print warning just printed out that, sorry, you know, we've got an assignment coming up. I thought I'd print that lovely don't plagiarize message. Any questions? Yep.
So you wrote return 0 in some of the things and in the others you did not. So like what does that return 0 or return 1 usually do?
Yeah, so return 0, if we're in the main, return 0 means like 0 errors, 0 problems, our code ran successfully. Sometimes we do error checking and we might say return 1 to indicate error. So for us, 0 means from the main, 0 means no errors, anything else means something went wrong. Yep. Yep.
So what if we indicate an error? We're just telling the system that there's an error. So like
Honestly,
instead of having return 1 or return.
for our course, these return values don't really matter for what we're doing. In an assignment, we might tell you we want you to return something if there's an error, and then that might matter. But really, for most of what we're doing, it doesn't really matter. It matters when you go to COMP1511, then these things sort of matter. All right, one more question, yeah?
Why is that? Why the computer knows it's going to print the star sign?
Because it's programmed in. So the thing is, we've written I wrote this function myself, right? So when we write our functions, this is another thing. Style-wise, we like to put these prototypes up the top. This shows anyone reading it and the compiler, these functions do exist. And this is the kind of input it gives and the output it gives. If I've got something that returns void, like a void return type, I can't have something like this. The compiler is going to say, hang on, this is a void function, what are you doing? then style-wise, we like to have the actual function code for these functions. So the prototype just has the inputs and the outputs, or return types. Down here, we actually have to write the code. So I've written this maximum function. I've written this print stars function. I've written this print warning. And again, style-wise, they should all have a brief comment explaining what they do. You know, yeah. Okay. Now, if I don't put these prototypes, what will happen? When I go to compile it, the compiler works from top to bottom. So if I don't have those prototypes, the compiler looks at these lines of code and says, what is maximum? I don't know what maximum is. And you get this error, implicit function declaration kind of thing. Has anyone already seen this error? When do you see this error? If you forget to do hash include std.io, it'll say the same thing. It'll say, I don't know what printf is. What are you talking about? Here, these are our own functions. I haven't put those prototypes there. It's going to say, I don't know what maximum is. I don't know what print stars is. I don't know what print warning is. Now, there is a way around that. I could, because it does things in order, I could stick my main function down here, and then the compiler knows, oh yeah, I know what print warning is and print stars and maximum. I've already looked through them. But the problem is this is considered bad style in our course, so we don't want you to do this. Why? We don't want to scroll through lots and lots. This is a small program. We don't want to scroll through lots and lots of really specific helper functions. The first thing we want to see is something like this, where we get a high-level view. Okay, I'm going to get the maximum. I'm going to print some stars and print a warning. I want to see that. Then I can think, gee, I want to know more about that print stars function, and I can go down and look at it. We don't want just things everywhere, like a messy, well, like my messy handbag with this stuff everywhere, my messy desk as well. So that's the way we like it. And having those prototypes at the top also helps humans reading it as well. They know, okay, there are these helper functions. All right. Hopefully that makes some sense. We're now going to write our own function, and by we, I mean we, not just me in advance, for the area of a triangle. Now, this isn't a maths course where we expect you to know the area of a triangle, even though a lot of you might. We're using the formula half times base times height. And it doesn't even really matter about that formula. We're not going to say in the exam, write code for some maths formula that you don't know. It's fine. So I've already decided I want to use doubles for the base and height. And I'm going to make an area that's double as well. I've got a printf, please enter the base and height, and I'm scanning in the base and height. Now, if I wasn't using functions, trying to write functions, what would I do next?
Double area equals.
Yeah, so area, because yeah, I've already defined it up there. Area equals what? Ah, I heard somebody say 0.5. Yeah, we don't want to get stung by this, do we? What do I mean? What's wrong with this?
So 1 is an integer, so 1 by 2 is
Yeah, that'll leave us 0. For something this simple, we can just put in 0.5. Now, this is going to give me the area, and now I could print it out. The area is something like this, area. Oh, goodness. Right? Does this work? Let's test it. I'm being one of these people that's testing something and I don't really know what I'm expecting it to give me. Okay. All right. Now, if I want to do this a lot or whatever, I might want to make, and just for a simple example, we want to make a function to do this area. So first of all, what do we want to call our function that's computing the area of a triangle? Yeah, I can hear people saying things like area triangle. I'm just going to call it area triangle, which is the same name as a file. Anyway. Now, what are the inputs this needs? Well, are we going to use what types? We want ints or doubles? Yeah, doubles. Double, base, double, height. And what is the return type? Double. Good. So this would be our prototype. And down here, we can write the code. Now I'm going to just steal the code I already wrote. All right. That's okay. And this looks nice. What else do I have to do? Return. Return area. So I've got my inputs, base and height, and I'm returning my area. Now up here, is this all I have to do? What else do I have to do in this main function? Yeah, I have to actually call the function. So the function doesn't just run magically because I've got the function written in my code. I have to actually say, I want you to go and run this function now. So I'd say something like area equals area triangle, and I'd pass in base and height. Oops, what have I done? Oh, put a semicolon in. So now, hopefully this works. Okay. So this is our own function. Now, don't get caught up with the different variable names or the fact that these variables are the same. These happen to have the same name. So, imagine I called this B and H, right? B, H, A, is this going to work still? Yeah. So what happens is, this is exactly the same. Main has its own copy of all of its variables, and they have their own names, base, height, and area. When we call this, we're passing in just an integer that gets stored and referred to as B and H in our function. Okay, the other thing is, I could call it as many times as I like. I could even just call it in here. Oops. Like this, right? Here I'm doing a function call. I'm saying go and find the area of the triangle with the base 5.5 and the height 3.5. That's giving me back some double number, and then I'm asking printf to print it straight away. Okay, so I don't even have to have that intermediate step of storing it in a variable if I don't want. I can plug it straight in to my printf. Okay, all right. All right. Any questions about that? Yep.
I wonder, this entire time, why is our main function sort of int main void and not void main void?
Yeah, because we're returning 0 at the end.
Oh,
Yep, so this return 0 corresponds to this int. Yep.
alright.
Yep. And again, I know it's confusing because main's a weird function that we don't use normally like we use the other functions. All right. Does everyone sort of understand the main concepts of functions? Okay, what's the time? Okay, we've got plenty of time. I've talked about the function flow. I've talked about this. Always choose meaningful names for your functions. Hopefully we know that, along with variable names. We've already had our quick break. All right, I want to show you one more function. Now, again, we've got this situation here, right, with this Pokemon. And we want to be able to print out stuff about a Pokemon without just repeating a lot of code. Do you think we can make a function that can have an input of an enumerated type, an enum? Yeah. So let's try that. Print Pokemon. So we're going to try and come up with a function called print Pokemon type, right? What's the input going to be for this? I just want it to be able to print out a Pokemon type. Like I pass in fire and it prints out fire. So the type of this, so when we have any variables using this enum type, this is the actual type, right? So instead of like int or double, I've got my type enum Pokemon type. Now I need to make up some sort of variable name for this. I'm just going to call it type.
Will int not work?
Well, what?
Will int not work?
Int. We really want to make it a Pokemon type, not any int. Yeah.
So it won't give an error, but it's better to use.
It probably possibly won't give an error, but it's better to do it like this. Even though we know it's sort of ints under the hood. I don't know, I can't remember if DCC will give it an error or not. Either way, we want to do it like this. What is this going to return? Yeah, void. We're just printing something. We're not asking it to tell us anything in particular. So we want to be able to pass in a type and be able to print it out with this function. Right? Now, I've already got code that kind of does this here. I'm going to steal this. But now, instead of all this rubbish, I'm being given a type. I just want to check if this type is equal to fairy, then I want to print fairy. If my type is equal to, and VS Code helps us with these sorts of things actually. If my type is equal to fire, I want to print fire. If my type is equal to water, I want to print water, etc. So this is my print Pokemon type function. Yep.
Can a function also take like a struct as an input?
Yep, a function can also take a struct as an input. Yep. So now, even though we've just learnt about structs and enums, they can kind of function like any type. I know that they seem more difficult than int, double, char that you've gotten used to, but they're just any type. We can pass them into a function. And depending on how you go with this, we'll do that too. So now, if I wanted to use this, let's just use it in an easy situation first. So I could say, up the top, print Pokemon type, and I'm just going to pass in, what type do we want to pass in? What do we want to print? I'll just print water. Yep. this is how I would call this function. I use the name of the function and I type in some kind of Pokemon type. Is everyone happy with that? I'm saying go and print water. And at the top, we can see it's printed water, right? If I typed in something like enum, Pokemon type, my type equals fire, and passed in that variable, what's it going to do? It's actually going to pass in fire into that function. So now it would print fire, right? So this allows us to pass in any of these values and it'll print it out in text for us. Okay, is everyone happy with that? How do you think we can use it down here? So I've got my Jigglypuff struct. This is hard, right? If you can understand this, you're doing well, this next part. I've got my Jigglypuff struct, and here I've got all of this stuff trying to print out whether it's a fairy, fire, or water. How could I use my function here? Yeah, someone just said I can call my function, which is called print Pokemon type. Print Pokemon type. I've got my Jigglypuff, and my Jigglypuff has a primary type. I want to print that type out. And now instead of having all of this stuff in the main, I've just got one line, go print my Pokemon type. Which type do I want to print? Jigglypuff's primary type. It starts reading a little bit more like kind of Englishy, hopefully. Now I do it again. If I can use my mouse. And I do it for the secondary type. So again, I get to get rid of all of this. And now my main's looking a lot better. I'll get rid of this at the top because that was just an example. So you may need to go back and look at the fine details of this code, but can everyone see the advantage of having this function, right? It's saved me copying and pasting. I've only got this function. I can call it whenever I like. If I had lots of Pokemons and I was printing out lots of types, it's there. Yep.
Why, just a quick question. Why do you write like the function that you have it and write at the bottom? Like, what's stopping you from just like writing it at the top?
Yeah, so when we write the function at the bottom, it's just a style convention. We could write it at the top and C would be fine, but your tutors won't like it. Like, yeah, we do the prototypes, then the main, and then we have the functions. Okay. The prototypes are just the inputs and outputs kind of thing like that.
Oh, so it's like, okay, this is what this is.
And then we have the actual code at the bottom. Is everyone happy with that? Hands up who wants to write a function with a struct input. Or will our heads explode? Let's do it. Now again, this is to give you an idea of even if every line of code, you haven't got on top of, this is to give you the idea. So I can write a print Pokemon function. What type is it going to take? Struct Pokemon. Yep. That's my input. And it's got a void return type. I'm just printing something. Okay. Now, when I print, oh, I've got to give it a variable name. I'm just going to call it my Pokemon. Just so we don't confuse it with the type Pokemon or anything else. Okay, now when we print a Pokemon, what do we want to print? Well, I'm going to go and steal a lot of this. Or not that. I'm going to steal all of this code actually. And now, instead of printing it out for Jigglypuff, I want to print it out for whatever Pokemon I was given. So in VS Code, you can use a shortcut to get all of those Jigglypuffs and change them all to my Pokemon at the same time, which is nice. All right. Is this going to work? So in Pokemon, in my print Pokemon, I'm just printing stuff out. I'm given a Pokemon and I'm just accessing all of its fields and printing it out. Aha. I've forgotten to actually call the function. I've got to say, please call the print Pokemon function. What Pokemon do I want it to print? Well, I've only got one. I've only got Jigglypuff. But if I had more, I could print whichever one I wanted. Did I spell this wrong? I've done something wrong. Oh, it's not print Pokemon type. It's print Pokemon. Okay. All right. So now it did work, right? It's printing out the right stuff. Now that main function that we had that was like that with lots of mess is a lot smaller. We've got a nice function print Pokemon. If this was a bigger program and we now had more Pokemons, I just call that function. I don't have to keep copying and pasting code all the time and ending up with a mess. So when you're going into assignment 1, I believe assignment 1s will have structs and enums. This is the kind of thing you're going to be wanting to be thinking about so you don't end up with a main like that where you just look at it and think, help, this is a mess. And you know, when you do copies and pastes, you make typos and then you're like, oh my goodness. So yeah, this is the kind of thing we can do and really, I hope, shows you how great functions can be. Now, one last thing before we go, we'll do a bit of a recap of functions in the next lecture at the beginning. I always like to recap it. I just want to show you an example of bad style. Now, this was written by Sasha, on purpose. As an example of really bad style, she's the lecturer that ran it in term 1. So this is her example of purposely bad style, and I love it. Okay, so honestly, I could not even work out what some of this code was meant to do. What can we see that's bad about this style? I can't even find the main function. Like, it's really hard to even find the main function. And that's because there's no vertical space, right? So even doing that, I now can sort of at least see the main function. Now, we should technically have a void here. What's even wrong with these comments? Like, why do we have 2 styles of comments in one? I don't know. Anyway, what else can we, I'll put some space there. What's wrong with this hash define in terms of style? Yeah, we should have all capitals. What's wrong with this function? What's wrong with this, hash define? What does it mean? What's this hash define mean? What's this constant for? I've read the whole program. I'm not sure what this means, OS. So that's not meaningful. So these are the types of things you don't want to do when you're doing your assignment, because your tutor will be there looking at it. And we manually look at your programs one, to give you a mark for style. There's a whole rubric you'll get, and you'll see what we're looking for. One of the things is, are your constants in capitals? Are you using vertical space well, so we can see what's going on? The other reason is, I forgot what I was saying. Oh dear. That's what happens when you're talking for 2 hours. I'm sure I'll remember it at some point. Or will I? Okay, what else is wrong with this style? Yeah, it's all together. Look, there's so many things wrong with this style. But also, for your own sake and your own, well-being, make sure, try not to end up with code like this, because you won't be able to debug it either.
For the struct name, shouldn't we follow Pascal casing as a condition?
As what?
Like capital I and
Let's go. And now, look, if I've got a question like this about style and I'm not sure, what can I do? Yeah. So, first of all, we've got the style checker. Actually, I should have run the style checker.
I just tested, it doesn't break, it's good.
We've got a style checker. The style checker doesn't tell us everything. Okay? Let's just see what it will do with this. It doesn't break even for this program.
No, it gives you all the warnings. I didn't fix it last time.
1511 style, bad style. Yeah, there's a lot here. Too much to look through. So, obviously that style checker helps, and you go fix all that. But you also need to find, there's some things it won't find as well. So we can go to the style guide and we can check what do we want for struct names. So same rule as variable names. So we just use snake case. So that is fine. Ice cream's fine. Again, we've got some really long printfs. There's some advice in here on how to space out your printfs better in the style guide. One other thing is, don't say mean things in your printfs either. Is that technically considered bad style? Error, you did not put in flavor and scoops, did you now? Don't write things like that. You didn't type in an integer, you idiot. Like that. Anyway. So, yeah, we're not going to have time to fix all this bad style, but I hope you can see how difficult that is to sort of read, right? And we don't want to replicate that. All right, thank you. Today's been a really tough lecture with lots of stuff in it. So well done.
Excuse me, I remember that the
Oh, hang
first week is not taken into account.
Just wait a second. Oops. Oops. Oh, thank you. Yeah?
Well,